Okay, I'm going to be going over the mole review. Please follow along. This is very similar to your exam, which you will be taking tomorrow. So you can see cross off number 2. We're going to start with number 1. What is the empirical formula for the substance figure? Okay, for empirical formula, there's several steps. So step 1, turn the percent into grams. And this does not require any calculation. You're literally just changing the percent sign to the letter G. So for sulfur, you have 40.05 grams. How am I going to find out how much oxygen I have? You would just take 100 minus the 40.05, and that's the rest of the pie, okay? Because these have to total up to 100. So oxygen is 59.95 grams. Step 1. Step 2, you're going to convert grams to moles. So I have 2 grams of a given substance. This is sulfur, this is oxygen. So to convert, I'm going to need 2 T-charts. One for sulfur and one for oxygen. So for sulfur, whatever you're given goes in the top left-hand corner. And for oxygen, whatever goes here needs to match here. The units have to match. And you can use that as a guide. Okay, if that says grams, then grams goes here. If grams of oxygen says right here, then what goes right here? Grams of oxygen. They need to match. Whatever I'm looking for, which is moles, will go right here. Whatever you're looking for goes in the top right-hand corner. And you'll always just put a number 1 there for now. Where am I going to get the grams? How do I find out that number? You're going to turn to your periodic table and look up sulfur, which is right there, 32.066. And for oxygen, I would do the same thing, 15.999. So we are still on step 2. Okay, now if we look at this, are we multiplying or dividing? We are going to find a different color pen. Divide. Okay? If anything is side by side, you multiply. If you wanted to, you could multiply 40.05 times 1 and then divide it by 32.066, but it wouldn't matter because anytime you multiply by 1, it's the same thing. So you can go ahead and just do 40.05 in your calculator divided by 32.066. Are we going to be in flow mode or psi mode? Flow. Make sure you're in the flow mode. If you don't know how to change modes, let me write my answer first. It's just the second button on the top left, second DRG. And then you can use the arrows here. Again, it's second DRG. That's how you switch back and forth to different modes. You want to use the scientific mode if you ever have an exponent. I'm going to go ahead and work on oxygen now. 59.95 divided by 15.123. Okay, and again, this was for sulfur. You converted for sulfur and you converted for oxygen. Now step 3, out of these two numbers, which one is the smallest number? Which one's the smaller one? The 1.25. So step 3, you divide by the smallest number, every single element. Okay, so if you had 6 elements, you're going to divide them all by 1.25. That means 1.25 is the denominator. So 1.25 divided by 1.25 is 1. And here, 3.75 divided by 1.25 is 3. These numbers that you just calculated, those are now the new subscripts. It's the lowest whole number ratio for empirical, but I always just say it's the reduced. It's in this lowest form. So S, we got 1. O, we got 3. Correct answer is C. Any questions on that one? Calculating empirical formula does take the most time. Okay, we're going to go to number 3. Which is the correct molar mass? Calculate the molar mass for the compound. So here, all we are doing is adding. Okay, we're adding up for total mass. So calcium weighs 40.078, and bromine weighs 79.904. But if we look in the problem number 3, how many bromines do we have? 2. We have to account for both of them. Okay, so the weight or the mass, multiply that by 2. Whatever number you get there, you add it. You just add those two numbers. So 79.904 times 2. I add these two numbers together. But after I did that, I got 199.88. Out of my multiple choice options, which one is the closest? Let's see. 199.8, they rounded to 200. So again, when you're calculating molar mass, you're getting the total mass of the compound that they give you, and you find that by just adding up the weights from the periodic table. Okay, number 4, you're going to see a lot of these on your exam. Okay, and you always need to start with whatever you're given. If this is moles of NaCl, what goes down here? Whatever we want or whatever we're looking for goes in the top right corner. It says moles, you can just put a number 1. Where are we going to find the total weight of Na and Cl? Off the periodic table, you find the mass of sodium, which is atomic number 11, and chlorine. And all you need to do is add them up. So that total compound, NaCl, the mass is 58.44. Are we multiplying or dividing here? Anyone? Multiply. When it's side by side, you multiply. Go ahead and multiply these two numbers together. Doesn't matter what order. I got 113.7. If you got another number, let me know. Okay, we're going to flip the page. Number 5 is very similar. Again, you're always going to start with a number that you're given. If this is molecules, what is this going to be? These will always match because they're going to cancel out. And then what you really want is the moles, and that goes up here. I'm going to read the problem to you. How many moles of carbon dioxide contain 3.79 times 10 to the positive 23 molecules of carbon dioxide? Anywhere in that problem does it say grams or mass? No. Are we going to use the periodic table or Avogadro's number? Avogadro's number. Okay? You only use the periodic table when it says grams or mass. So I'm going to you put a 1 here where it says mole, and then in the other blank spot, you'll put Avogadro's number. Are we multiplying or dividing here? Are we going to be in flow or psi mode? Psi. So turn it to psi and just divide these two. Okay, so let's see if you can see. 6.02, or 6.29, I'm sorry. It's difficult to see with the glare, but then way over here there's a little exponent, and it says times 10 to the negative 1. If I look at my answer choices, that answer is not there. So I'm just going to try and putting it back into flow mode. So put it into flow mode, and then it says it's just 0.629, which would be my answer choice A. If that ever happens on the exam, you calculate something and one of the answer choices aren't there, try turning the modes into one of the other modes or call me over and I can help you. Number 6, which term is described as the lowest whole number ratio? Out of these vocabulary words, which is considered the lowest whole number ratio? Is it empirical or molecular? It's going to be empirical. Empirical is the one that I said is simplified already. It's already reduced. It's at the lowest ratio possible. So empirical is reduced already. Number 7. Again, finding the empirical formulas take a little bit of time, so let's knock this out. I'm already going to change these. It's not 70% iron. It's 70 grams of iron. It's 30 grams of oxygen. So I already did step 1. I converted the percent to grams. Step 2 is convert the grams to moles. We have grams. We're going to change that to moles. I need 2 T-charts because 1 is for iron and 1 is for oxygen. Whatever I'm given, that's what I start with. Whatever unit is there, it's the same unit here. And what am I looking for? Moles. Whatever you're looking for goes in the top right-hand box. So I'm going to put in number 1. Where do I find grams of iron? On the periodic table. Iron weighs 55.8. Oxygen weighs 15.9. For both of these, are we multiplying or dividing? They're top to bottom. I'm going to call on you for the answer, so divide 70 divided by 55.8. And now do 30 divided by 15.9. Okay, now to step 3. I'm just going to write a 3 here. Which of these numbers is the smallest number? The 1.25. So you divide both of those numbers by 1.25. 1.25 is on the denominator. 1.25 divided by 1.25 equals 1. 1.88 divided by 1.25 It's 1.5, but I'm going to round up to 2. And if that happens on the exam, I'll let you know whether you need to round up or down. Okay, so now you're done. Remember, this was for iron. This was for oxygen. So those numbers become the new subscripts. So out of my answer choices, the correct answer is D. Remember, you don't have to write the subscript of 1 because it's already known that there is 1 there because you wrote FE out. Number 8, how many grams of CCl4 needed? Right away, just start with writing what you're given. If moles there, moles goes here. What do I want? Grams, so that goes at the top right. Put a 1 there. Grams of what? CCl4. How are we going to find how much CCl4, what the mass is? Look at the periodic table. You see how I multiplied it by 4? Why? Because there's 4 chlorines. It has a subscript. That means there's 4 of them. You need to account for all 4 of those molecules. When I add these together, I get 153.6, and that is the number that goes here. Am I multiplying these two numbers or dividing? Go ahead and multiply them. I got 768.055. So the closest to that is going to be C. Number 9, I'm going to start with whatever I was given. If that's moles, moles goes there. What am I looking for? How many grams? Whenever you see how many, that's what you're looking for. Where you see mole, you just put 1. I need to find the weight of 2 hydrogens and 1 oxygen. Am I multiplying or dividing? Go ahead and multiply them. $35.98. The answer is C. Any questions so far? If you know what you're doing here, you're going to do well in your exam tomorrow. You just have 3 more to go. You can go ahead and cross off number 13. Okay, so as you get better at this, you just can speed along. Number I was given here. If you're ever wondering like grams of what or how did I know to put NH3, it's because it's the only element in the problem. Okay, there's no guessing about what element to put. These always match. What do I want? Where do I find the grams of NH3? How do I find out how much that weighs? Periodic table. And I just add these two. When I added them together, I get 17.03. Are we multiplying or dividing? What do you guys think? Divide. Okay, go ahead and divide them. What did you guys get? 6.289. So out of the multiple choice options, we're going to be C. Okay, 11 and 12 are very easy to do. You're just finding a percent. Okay, just like when you're trying to figure out what your grade is or what you made on an exam. The formula for that is the part divided by the total mass. So this is the formula for a number 11 and 12. Okay, what is the percent composition of CO? So you need to find the total mass of C and O first. So C equals 12.011. So that's the easy part. All you're doing is adding those together. So that weighs 28. It's 28.001, but I'll leave it at 28. Okay, so that's the total mass. Okay, now I want to find out, well, what percentage of that is carbon? What percentage of it is oxygen? Well, I put as the numerator the top number right here, however much it weighs individually by itself. That's what the part means, the individual. 12.011. So I'm going to find the percent of carbon first. So I just do 12.011 divided by 28 gives me 0.428. I times that by 100 and it gives me 42.8%. So I'm going to look at my answer choices. The percent of carbon, it's not 50, it's not 12, it's not 25. D looks the closest. 42.8 rounds up to 43. And therefore, that's my answer. I don't even need to mess around with any more calculations or figure out the percent of oxygen because it's your only answer choice. Okay, for number 12, you're going to do the same thing. Find the weight of copper. 63.5. And then chlorine, 35.4. But I need to multiply it by 2 because there's 2 chlorines. So it equals 70.8, and then I'm going to add them together. 70.8 plus 63.5. 134.3. So that's the total that goes on the bottom. I'm going to start with copper to find out how much copper is in it. 63.5 divided by 134.3. It gave me 0.472 times 100. It's 47.2%. For copper, I'm going to look at my options. No, it's not 33, it's not 50, it's not that. This one's the closest, 47.2. That's my final answer. I do not need to figure it out for the other one. I'm going to come by and get your grade. Again, the exam is tomorrow.